last problem here. We're going to do the ratio test. So let's just get that started here. And if we're trying to find the radius of convergence, that's after we get to the end. We kind of see what that diameter of convergence is. Again, that's not an actual thing, but that's how we go about it. So ratio test, we start with the limit as we go to infinity. And n plus 1 piece is going to go first, so I'll just write that out. So isn't x plus 2 going to be to the n, and then times another x plus 2 to the first? You guys seem okay with that stuff, right? And then this, does that say n plus 1? Yeah. So if I do n plus 1 in that spot, it would end up being n plus 2. So that would be 3 to the n times 3 squared. And I'll just leave it as 3 squared. Obviously, you could write it as 9. And then multiply, and we reciprocate this. So we do 3 to the n times 3. And then n times x plus 2 to the n. And then you make your sound effects. And the 3 will cancel the squared out, right? And what stays inside the absolute value? That stuff comes out of the absolute value.
Okay, yeah. Then 3x plus 2.
So we've got the n plus 1, and I'm going to put 3n down here because there was still that 3. And then in the absolute value, we've got the x plus 2, so that looks good. Questions on that at all? What is this limit? 1/3, so we get our 1/3 absolute value of x plus 2, and that has to be less than 1. So then if we get that 1/3 out of there, we'd multiply by 3, so then we know absolute value of x plus 2 has got to be what? Just smaller than 3 there. And then, yep, we can put it right in between -3 and 3. Subtract 2, and we get -5 and 1. So the diameter there would be what? 6, so the radius would be 3, right? And you can see that right here, but I just don't want you looking at the wrong spot and saying it's 1 instead of 3. So I always get to here, and then I decide. So our radius of convergence is 3. And then we have to determine if the endpoints are on there, and this is where you guys were saying that was a little more difficult, right? So let's test -5. Let's do it together here. Okay, so if I plug -5 in for x, this turns into -3 to the n. So let's just write it out. We'll put it in the series in a minute. So we've got -3 to the n. And then down here, it's just 3 to the n plus 1. I feel like I might try to clean this up a little bit because I've got a -3 here and a 3 there. Process that for a second, see if that makes sense to you. I'm combining the -3 to the n on top with the 3 to the n that's on the bottom. Because the bottom's 3 to the n times 3, right? And the top is -3 to the n times n. So I just am putting this together because that's just going to turn into what? -1, right? And so if we've got our -1 to the n, and then we've got our n, and obviously we've got that 3 in the bottom, that's what I'm going to put into the series. So our series starts at 0 this time. Just copy what it started at in the problem. So I've got -1 to the n. The 3 you could really pull out front if you wanted to. And we're just timesing by n. So as I plug things in here, okay, you plug in 0 first, and then you plug in 1, 2, 3, 4, and you're adding all of those up. Aren't those numbers getting bigger and bigger? So what is this going to do? It's going to be divergent, and there's not a test you would need to do. I suppose you could probably do some sort of a test for that. Ready? Okay, so this alternates, but it's getting bigger and bigger as it's alternating, so it's not approaching anything. We said divergent there. And then the other endpoint we've got to check, so we're not including the -5. The other endpoint we've got to check is 1. Okay, so if we test x equals 1, isn't that going to be 3? And can't we really do the same thing that happened right here, except for it'll be 3 instead of -3, so that's just going to turn into a 1. So really, we've just got n over 3. Does that make sense? So what's going to happen to that one? So you can pull the third out front if that helps you. Can you just say it? You would think so. Okay, if you plug in, we've just got that third out front. If you plug in 0, and then 1, and then 2, and then 3, and then 4, we end up with a divergent, right? So same idea as the last one. What? Yeah, that doesn't work, but that was a good try. It's just because it's the only thing he's gotten wrong, you know, so. So this would actually be our answer without either of the endpoints being added into it. Whoops. Any questions on that? You'll probably have questions on your homework as you're going. I sent you answers, so you've got that to reference, but try to do some of the problems, you know, before you check them. That'd be good.